Welcome back to Climbing the Interface Ladder, lecture number 3, Customized Interfaces. So before the break we saw how we could synchronize the data between the server and the client. So we only synchronized the data when, the interface was opened, so we didn't have to synchronize it, whenever, but just when the player had the interface opened. But we didn't really finish that part, we just had the synchronization when the interface opened, but not when it was open. So let's head over here, and as I mentioned before, this code here is a bit inefficient. We're sending like 49 sending the data 49 times, where we could compress it and only send it 4 times. But that's going to be a part of bits and pieces, course number 6. So for now it's going to be have to do it for now. So we send 49 Boolean values and then we receive them here and store them on the client side. So now it's time to do the same, a similar thing here, detect and send changes. Okay, so that's going to be fired, quite a lot, like all the time, basically, so it wouldn't make sense to just send the information like this. We obviously know when we open the interface, then we need to send all the information. Because, the player just opened the interface, give the player all the information. But, continuously we don't want to give the player all the information, because obviously everything hasn't changed, so there's no reason to send things that haven't changed. So what we want to do is have a private boolean old data here, like so, 49. That is going to store the old data, like the previous data that we had. And it's important that we put this in the container rather than in a tile entity. So in the tile entity here we have the current data, that's the custom setup here. But if we store the old data here as well, then we would just have one single old data. Okay, that's fine, right? No, it's not. Basically, we have different containers for different players. Remember, when we open a container, an interface for a player, the server side is going to create a new container for us. It's not going to have one and only container for all the players. It's going to have one each time we open an interface. Therefore, if we store the old data here, that old data there, can't select it, all data there, sorry, in the tile entity itself, what we'll do is basically the first player to synchronize the data will tell the tile entity, alright, this old data has now been changed to this new thing here, so you only need to send if there's a change. But if we already consume that change, then it's just going to be sent to one player. So what we'll have to make sure is to put it in the container. If we put it in the tile entity, it's not going to work properly with multiple players. And I've learned that the hard way. So there you go. Just do it like that. And what we want to do then is, I said that we had one container for each player, and that's mostly true. But one container can actually have multiple players as well. You didn't really see that too often, so I'm not entirely sure when it happens, but we need to support that. So we need to loop through all the players that have been added to this container. So it's possible for one container to control multiple players. And if that's the case, then we will have to loop through them all. But remember, they are iCrafting thingies after all. But the list here is not of a specific type, and that's why we have to get them as objects like so. And then when we've done that, it's just a matter of loop through the data like this, like with the before when we sent it in the first place. There you go. But here's this part that is different from up here. We want to check that this is actually something that has been changed. So custom setup I is not equals to old data at the same index there. So if it has changed, I don't know in which direction, but it has been changed somehow, and if that's the case, then we want to send the information. Because if we just send it all the time, we're going to send a lot of information to the clients, and that's just a lot of extra server load, so there's no reason to do so. But if something has changed, we obviously need to send it to the client, and we do so by referring to iCrafting like so. And then we obviously use the same thing, send a progress bar update. That's that one. And container, this one, the index is I there, and then we want to send 1 or 0 because that's how we set it up. And like I've said multiple times before, I just want to stress it. this is not an efficient way of sending it. We should pack it into boxes before we grab it and go with it to our friend, the little store I had there. But for now, we're just going to grab it in our arms and go a lot of times instead. So that will have to do it. So what we do, we loop through all the players, then we loop through all the information we want to send, and if the information is different, then we want to send it. What we can't do here is just say, alright, let's update all the data to be the same as custom data, because that's sort of what we want to do. After we're done, we want to set the old data to be the same as custom one. But the problem is, we can have multiple players here. And you know, if we have multiple players, then if we change it once here, then we won't have the if statement here being true anymore, because we just set it. So it's just going to synchronize for the first player inside the container if we have multiple ones. Then you might think, well, we can just reverse these like so, and then just well, check it first and just put the player loop. We could put the player loop in here, for instance, that we loop through all the information, and then if the information is not correct, then we can just go through all the players and send the information. Yeah, that's totally possible. But the reason why I don't want to do so is, well, we might not have all the information, like all the information that we want to send in a loop. Well, we might not be able to refer it through a loop, sorry, because we might have it in different variables from different locations and so on. Now it's very easy, we just have an array and we can just loop through it all. So that's why I'm not going to do the smart thing in just this case and just move this in here and, you know, do it like that. So I'm just going to show you how we would do it otherwise. So otherwise, what we want to do is we loop through all the players and then synchronize the data, and then when we have done that, when we are looped through all the players, then we can update the information, because then we have synchronized it to all the players of this container, and then it's just a matter of updating all the data. And how do we do that? Well, what we can do is, for instance, arrays.copy of machine dot custom setup machine dot custom setup.length. There you go. And import java.util.arrays. So what we do here is just take a copy of the current data and set it as the old data. So what detect and change and send changes does is basically it compares the current data of the tile entity with the data that we have stored in the container. The container will then go through all the players and see if there's a difference between the current data and the last time we tried to send any changes. If that's the case, then we want to send the changes, and in the end we want to update the old data to completely match the current data. So next time we go through and check for changes, we can see if there has been any changes in the current data, just because we saved the old one. And remember, we have to copy it, because if we set it to machine.custom setup, then those, well, the old data and custom setup will refer to the same array. And since we then send the thing here with send progress bar update, we will still receive it in the update progress bar. So we use two methods to send it. One where we send it all, and that's going to happen when we open the interface, and one when we send the changes, and that's going to be done all the time, but we obviously just want to change it if something has been changed. Well, yeah, we just want to send it if something has been changed, and if that's the case, we receive it at the third method there. So 3 methods are the things we need there, and of course we need to refer to that method as well, send progress bar update. And that's everything we'll have to do. The container itself will take care of, well, is this player looking at this interface and so on. We don't have to care about those things. That's going to be handled on its own. Let's take a look. Okay. It's just a matter of starting this here. And when we've done that, we can take a look. Get rid of that. Look at that! Look at that. It's updating right away, and if I close it and open it again, it's going to stay the same there, because when we open it, it's synchronizing all the data, whereas when we just click, it's going to say, oh right, there's a difference here, let's synchronize that part. So now all of a sudden we can well, send the information we want and receive the information we want properly. And this is a very powerful tool, because now if my friend is modifying something there and I'm running it around here, there's no reason for me to get it. That means that we can send a lot of information without having to overload anything. We just send it to the players that have it opened, but we also know that the players, when they open the interface, they will have all the information. Yes, because when we click it, it's going to send all the information to us. And it's the same thing when we have like items in here and so on. Those are being synchronized in the same way, and the same with the furnace. It's just synchronized into data like so. And it of course has some drawbacks, but they are not well, they are nothing compared to the good things about this. So the good things, we don't have to send it to anyone else, and we know that we get the information when we open it. But of course the drawback is, since we send the information when we open it, you probably have seen this if the server you're playing on is a bit slow. When you open any like a furnace, a chest or something like that, it might take a second or two, or well, not that long, but a fraction of a second or two rather, before the items inside the interface actually appears. And that's because of this. When the player opens the interface, then the server is going to send in information to you, and it might take a tick or two before you actually receive it. So that's a bit of a drawback. It might take a tick or two before you can see the updated information, but it's very good because then we don't have to send the information to anyone else. So I would highly recommend doing it this way, because this is basically the way it's done. Right, so now we can set that, but we're still missing a few things to make this work. So what I'm going to do now is actually add functionality. That seems like a good thing, right? Not just fancy things. So what I'm going to do is head over to block machine. That's this one here. And head over here. Here's the dropping code. So if it's the type 1, then we want to drop it like that. Type 2, type 3, and so on. So here we go. Case 4. So in the instance of it being case 4, let's add a break there. We want to loop through like this. Machine dot custom setup dot length. Remember, we have already, from previous lectures, we have already defined machine there. I think it was from lecture 1. So we have the machine there that is usually just used as the inventory, but now we can use it to get some information here as well. And there we go. And what we want to do here is basically just do this custom setup there. We check if that's the case, like so. And if that's the case, that, well, this part is actually set, then we want to drop an animal here, right? And how do we calculate this? Well, the drop x coordinate should be x, that's where the block itself is, but then we will use the settings here as an offset. And depending on how we define the indices, in the beginning, I can head over there, here at UI machine, and in the top here, we defined them like this. So it depends a bit on how we define them, but it doesn't really matter because we don't really have an orientation in the world. We have an interface, we know what's up in the interface, but where is that in the world? So it doesn't matter too much, but what we want to do is just do x plus I divided by 7, like so. It's not supposed to look like that. And then we add minus 3, like so. The reason why we do that is because then if we have coordinate 3, 0, 1, 2, 3, that's going to be in the middle. So that basically means that if we click in the middle rectangle, that's going to be in the very middle. So it's not like we have a grid off to the right or something like that. We have the grid centered around the block itself. And then it's just a matter of doing the same thing for C here, C plus I, but in this case we want to do mod 7, so we get the other dimension there, and minus 3. And now when we have those things, it's just a matter of doing spawn, and we give it the world, we should give it the machine, we should give it the drop x, a y, and the drop c, like so. There you go. Done. Let's see how it looks like. Here we go. Oh, sorry. That voice. Here we go. Sorry about that. So now when we have this default card here, when I click here, it's going to drop all the things that we have selected. So if I just select these, 4 guys there, and let's select it like that as well, something like this. if I click it now, it's going to drop them there. Oh right, I messed up. So there you go, now they were dropped here on the ground. So the reason why is obviously because the y coordinate I set is you know, it's just 20 not 20 blocks up in the air that I usually set it. So obviously it just places them on the ground, but it places them properly. So as you can see, it places them in the shape here, so we can use that for now, but the next time we run, we'll do it properly. So for instance, if we set it differently, we can like deselect these ones, do it something like this. There you go, and a happy face. And now if I click there, they are all going to spawn, but obviously not in the air. Yes, because I messed up there. We should spawn them up in the air there. That was spawned in the air because I stepped on the block itself. So there you go. Yes, because we have custom there, we do it like this. But we have two problems more than the one I just fixed, and those are here's the first one. It's not saving, and the second part is it always tells us that we had 12 annuals per drop, and that's not the case. So we should fix those two, and then we will add another feature afterwards. So the saving part is quite easy. Well, let's do the saving part first. I was considering that part first, but head over to tile into machine here, and then to read and write to MBT. Here we go. And what we want to do is the following. But like when we synchronize the data, we're going to save this a bit inefficient. We're just going to save 49 Boolean values. We could save something that would just be a seventh of the space, or a seventh, I think. So we're actually saving something that is 7 times bigger than it has to be. Well, yes, because we can't compress it properly. But like I said, that's going to be the topic of the well, of course, number 6, the bits and pieces one. Set Boolean, and then we have custom set up. There you go. So what I'm doing here is just looping through the array and then adding tags here. I have custom as their name, but I also add a index at the end. So we have like custom 0, custom 1, custom 2, and so on. And then we just save the value there. And then we can just do the opposite when we read. Remember, reading is the opposite of writing. Like this. Setup.length. And what we want to do this time is just do custom setup I like so equals compound dot get boolean like so. And then we add I like that. There you go. So like I said, this is not the best way to save it. We could compress this if we wanted to. So instead of saving 49 Boolean values, we could save 7 bytes, and 1 byte takes as much place as a Boolean value. So basically we can save 7 bytes rather than 49 bytes. But you know, that's not the topic of today. That's the topic of course number 6. So we'll just ignore it for now. So how do we fix the text? The text is obviously wrong. Well, what we can do is head over to wherever that is. That's the wrong thing, but we want to head over to the interface. GUI, I should have it there. There we go, sorry. And take a look at the text. Where do we define the text? Well, we do it here. And we have, if type equals 1, then we set the count to 5, otherwise the count to 12. So that's why it always said 12. So what we want to do instead is just say, well, else if type equals 4. Then we'll set the count to what? To 0? No. To the current amount that we have. How do we define that? Well, we could do it like this. Custom annuals. Well, that wasn't really what I planned to write. Machine.get custom annuals. So we asked the Thailand how many custom annuals do you have at the very moment. Obviously we will have to calculate this. But how do we do that? Well, we can do this in a few different ways. But the way I'm going to do it is private int custom anvils equals 0, so we start at 0, and then we just return that for now, like that. So that's how we can get them. But how does it change? Well, I can make a method here called public void set custom anvil that we can use instead when we actually set the content here, and that one can do more than just well, setting the value. We can also calculate how many we have. So for instance, we get the old value. So that's the value we just had, and then in the end what we want to do is set it to the new value, okay? Okay, so far so good. But the reason why I get the old value is so we can compare it easily with the value here. We can actually just do it like that. So we get the old value, then we set it to a new value. So if we did have the old value, okay, so if it was active before, but it's not active anymore, that the new value is false, then we want to decrease the amount of anvils we have, because we basically just removed one. However, if we didn't have the old value before, it was inactive before, but all of a sudden we activated it, so value is true, then we want to increase custom anvils. So there you go. So now if you set custom anvil instead of using just custom setup I equals blah blah blah, then it's also going to count them when we set them. So if we want it to work on the server side as well, we need to, well, use it here as well. We're never going to use it on the server side, but just, well, for the sake of it, like so. So that's how we do there. And then we also need to do it here when we read the information, like so. But the important part is to make sure that it works on the client side. And to do so, what we have to do is head over to the container itself, and well, this is the only part where we set it on the client side, when we synchronize it to the client. So what we're doing here is just telling it, well, set the data.id there to be this thing. I need to refer to machine, obviously. But what set custom anvil also does is to keep count on how many we do have, and then we can just get it from here and use that as our count. So now we're saving it, and we're also defining how many we have, while showing how many we have. Let's move this up, not resize it. Okay, so what do we have here? Well, there you go. As you can see, when I activate these things, it's going to increase the amount, because it realizes, oh right, you just added one. If I click on one we already had, it's going to be decreased, because it realizes, oh right, you just removed one. So now it keeps track on that, and it's also going to keep that in mind when it calculates if I have enough. So boom, all of a sudden it goes red. Yes, because now it requires 16 anvils per drop, but we only have 15. We haven't added anything that is going to prevent from dropping, of course, so it's still going to try to drop, but it's going to miss a few. So if we try to drop that shape, we'll see it didn't have that last one there, I think. Yeah, that one was missing. So there you go. But if we log out and log in, or well, exit the world and go back in again, we will also see that it has saved it all. But, you know, it's quite a lot of clicking to make sure that all of these things, like if I want to set them all, it's quite tricky. I have to click a lot, and I'm just misclicking all the time. So what I'm going to add here as a last feature, just to give some more example of what you can do, is to use another method in the interface so we can actually, you know, click and drag to set multiple ones at the same time. So, well, let's get going with that. Okay, we'll also see some problems with doing that, so we also will obviously see the solutions. So that's the last thing here. Okay, so what we want to do here is override another method, and we have mouse click move or mouse moved up. And we're not going to use mouse moved up, but I want to talk about it for a second. It's at the very bottom of the screen. Oops, there you go. I imported the other one. But the mouse moved up, let's put it here, so it's easier to see. This one here, mouse move, well, mouse moved or up. The thing with that one is, it doesn't do anything when we move the mouse. So mouse moved is a completely wrong name. Basically what that one does, don't listen to the comment here, that's not true. What it does is basically it's being fired when you click a button or when you release a button. it's not going to do anything when you move it. That it did that before, but nobody has bothered about changing the name. Of course, there's no one to blame because I haven't changed it either. But don't think that it's going to do anything when you move the mouse. I just wanted to know, well, tell you about that because it tells you that it should do that, but it doesn't. That's an old feature that was removed from that method. But what we want to do is mouse click move instead, and what that's going to give us is the X coordinate, the Y coordinate, and well, the button, and finally the time since clicked. We're not going to use that one. And what this method does is that if we click and then moves the mouse without releasing it, like, you know, we click and drag and then we release it. If we do it like that, then we're going to, well, this method is going to be called each time we move the mouse. So it's not going to be called each time we move the mouse only, but if we move it without having released a mouse button. And then we get the button, of course, that we're not releasing, that we're using to drag it there. So what I want to do here is sort of similar to when you just click it, okay? But it's going to be very weird if we just send the information right away. Like, alright, you click on this and then you drag it along and then you're going to swap everything you have. It's going to be very tricky to handle because maybe you want to fill everything and then you move the mouse over something that has already been filled, something that is already active, as an anvil drop, I guess. Then that is going to be deactivated because, well, you moved your mouse over it. So it's going to be very tricky to use. So what I'm going to set it up is, well, if you click on an active one, that's obviously going to become inactive. But then if you move on any other active one, those are also going to become inactive. But if you click on an inactive one, then that's going to become inactive, and then you can activate the inactive ones. So instead of being able to both, you will just have the power of changing the one you started clicking on, and then you can just release the button and click on the other type if you want to. So that's how I want to solve it. And to do so, we obviously need a value that saves which state we are in here. I don't really have a good name of this, so I'm just going to call it current mode or something like that. And then what we want to do is set the current mode up here. So if we click with the mouse, basically, then we want to set the current mode to whatever we have here as the current what's called the machine dot custom setup there at a specific index. So yeah, so we just set it to whatever it was before we clicked. Even though it's after the actual packet code there, it's not going to have time to update. We're going to get the information there. So that's the old mode that we sort of had, the old thing we clicked on, and that's what we want to look for in here. So what we want to do is something quite similar to the mouse click code, but like I said, a bit different, but not a lot. Okay. So if machine.custom setup, like so, equals well, current mode, so that it is the same as the thing we just, well, used when we clicked it, then, well, of course, if it's also in the rectangle itself, otherwise it would be a bit silly, then we want to send a packet. So we're doing pretty much the same thing, but we're making sure that it's also the correct type. So we don't try to revert everything, because if we do, it's just going to be a mess. Everything is just going to blink back and forth all the time. So we want to convert it in one direction, and that's it. Packet handler dot send button packet, like so, and then it's just a matter of you know, byte, like so, and then 2 plus I, so the same thing as before, and we break out. There you go. So there you go. It's pretty simple. We just use the drag mode here and check that it's the same as the one we started with. But we'll see some problems with this, but to see them we need to start Minecraft first. Here we go, and well, now we should be able to click and drag, and it should change because we send the packets to the server even when we do it like that. So if I click on this one now and there we go, I can remove them by, I'm not clicking anything, as you can see here. And it's going to remove them, and we're going to get blank ones. But as you can see, it's very inconvenient. It doesn't really work properly. In the end, it matters, but if I just drag it down now quick, some are going to be left blank. Why? I don't know. Look at this, it's not really working properly. And the reason why it's not working properly, let's take a look in the code, is the following. When we, well, change the state of something, we only want to do that if the machine's custom setup is the same as the current mode. As soon as we send a packet, what's going to happen is, well, when we receive the packet, we're obviously going to send that to prevent us from sending any more packets, right? Well, that's true, but we're not going to receive the information right away. So we're going to send a packet to the server side. The server will then send the information back to us. So that's going to be a bit of a delay. It's not a big delay. We might not actually even realize that we have a delay unless we have a bad connection. But you know, the client might still have time to send 2 of these packets, and if we have 2, it will receive, the server will receive 2, and just swap them back and forth. It will swap them once and swap them again, and we will be where we started. So before we actually get the information that we did the first swap, we try to swap it again. So this is a bit of a problem because it didn't really work properly, and we can solve this in 2 ways, which they both have pros and cons. One way would be to send along the information, what do we want to change it to. At the moment we just send an information to, well, we just click this button here, we want you know, we want to swap it back and forth. That's what we did, but well, we can just say it, well, we click this button, can you change it to on? We click this button, can you change it to off? Because then if we send 2 packets, we're like, oh, can you change this to off? Can you change this to off? It won't go back and forth. It will just turn it off twice, which won't really do too much. And the good thing with this is, well, if 2 players look at the interface at the same time and they both click the interface, I want to turn this thing off. If they both do that, it doesn't matter. Both told it to be turned off. So yeah, it's just going to turn it off, and alright, someone else is doing this as well. I don't have to bother about that. But however, if we do like we did now, what we'll have to do instead, well, what's going to happen instead, if 2 players want to turn it off at the same time, then it's going to receive two packets, and it's going to turn it on and off. So it's just going to go backward. So that's a bit of a problem. We have a small space of time there where 2 players can click at the same time before they receive the information, and you know, that's going to happen. Another solution is that is not going to solve that part, but it's going to solve our dragging part, is to set the information right away here, and that's actually the way I'm going to do at the moment. But like I said, there are pros and cons with both of these things. The pro with this thing is, well, we don't have to send multiple packets. Otherwise we would just send multiple packets, and it wouldn't have to bother about extra ones that just appeared. But the con with this is obviously that we set it right away on our client side. That doesn't mean that we do anything else to any other clients, which means that we can still have the problem where multiple players click at the same time, and it will just go back and forth very quickly because the other player didn't receive the information right away. But well, that's good. This is going to solve this problem here, and the good thing is we don't have to send any extra packets. So what I'm doing here is just, as soon as we do the movement, we change the mode here, we do the swap on the client side. Then we will of course also send a button packet. That's necessary because the server will have to know about this, and the server will then tell all the clients about it. We're just, well, taking a shortcut to tell ourselves about it right away, just to make sure that we don't send it again. And we'll also have to make sure that we do that when we click, because otherwise we will be able to just blink back and forth at the one that we started with, the one that we clicked in the first place. So there we go. So like I said, 2 solutions. One is to tell the client itself that, alright, we've made this already, take a shortcut and modify yourself. In no way you can just ignore sending the packet information to the server. The server needs to know about this. Otherwise, well, no other clients will know about it, and the server won't be able to use it either. And the other solution is obviously to send some extra information. So we send like, alright, turn this off, rather than just swap it, because then the server can just use that information to do it properly. So now if I drag here, it's working completely properly. So nothing is blinking back and forth, and it's just working like a charm. And then if I click on a green one to start with, I can remove the green ones. If I click on a gray one here, I can only use the gray ones, even though I have green ones that I can hover. It's not going to do a thing. There you go. So now it's very easy to do a lot here. If I want to like remove the whole thing, I can easily do so. I can fill the whole thing very fast, like so. And then when I've done so, I can very easily just do the shape here that I want. But of course, I can still just click as well. I don't have to drag, there's nothing forcing me. We still have the click code there, and now we have the inverted face there. And if we give it some anvils like so, hit the button, and it's very tricky to see because we didn't have a border of any kind. But there we go. That's today's lecture, basically. So, short summary of what we have been doing. There you go. So first of all, we spoke about how we could use the mouse to check if it's in a specific rectangle, and we need to think of two things. Well, we need to keep the GUI left and top in mind. If we compare it with a rectangle that we had in the beginning, where we actually, well, had that as a part of it. So remember, in the beginning we had rectx equals GUI, well, not GUI, GUI left, rather, plus 57 plus I times j. Then we have GUI left there already, so then we don't have to bother about it. Well, then we have to bother about adding it. But if we have a rectangle that is set up with the GUI rectangle, then we obviously need to keep the GUI, the interface position in mind. So you need to think of GUI left and GUI top. So either you will have to modify the mouse to do so, or you will have to add that when you actually create a rectangle of some sort. But then we get to the special code here to check if we have the mouse in the rectangle, and it's fairly simple. We have checked that the mouse coordinate is to the right of the left edge and to the left of the right edge, basically in between the left and the right edge of the rectangle. And then we do the same thing of for the Y position. So we make sure that the mouse Y is further down than the top edge and further up than the bottom edge, which is basically saying that it's in between the top and the bottom edge. And if all of these four things are true, that means it's between the left and the right and the top and the bottom, which means it's inside a rectangle. Then we use this for drawing things as well. We use it in draw container background layer, but we also use it here in a method called mouse clicked. So here we can get information about when the mouse has been clicked. So we have X, Y, and button. Button is 0 for left clicked, and 1 for the right one. And here we just loop through, we check if it's in the correct rectangle. So there we go, check if the rectangle was clicked, rect.in rect there. And we finally want to send that information to the server. This is obviously not necessary if the button is not supposed to do anything for the server or any other client. But in most cases, when we click on something, we might want to tell the client, the server and the other clients about it. But maybe it's something that is just specific to our client. Maybe it's like a tab that we want to open. Then we obviously don't send it to the server if, well, different players can have different tabs open at the same time. Then we had the synchronization part, and that's the, well, I guess the most important part from today's lecture. How do we synchronize things in interface properly? And this is a very, very, very powerful tool when it comes to interfaces. How do we synchronize information? Because the client is not going to have all the information that the server have unless we give it that one. So what we do here is we use add crafting to crafters. We get one parameter, and that is the iCrafting that we call player, and that's basically a player that is opening this interface, but this is happening on the server side. What we want to do is just synchronize everything as it says there in the bottom, and what we want to do is just, well, synchronize everything. We can, every time we synchronize something, we do player.send progress bar update. We give it the container, the ID, and finally the data we want to send. And like I've said multiple times before, this is the way we do it here when we just send 49 different Boolean values is not that optimal, because, well, what we can do is just compress them to 4 shorts instead. But like I've also said, that's not a part of this course. Then what we want to do here is, well, use the update progress bar method, where we get it. This is on the client side. We get the synchronized data, we get the ID and the data that was sent, and observe that the values of those are actually shorts. Even though they are defined as integers here, we can't synchronize something that is not a short. It will be synchronized as short. And then when we get the data there and the ID, we can just use that to send, well, apply the information on the client side. In this case here, we just do machine.custom_setup. We refer to the index there with the ID, and then we use the data there to define what we're going to set it with. So we just send it from the server side and retrieve it on the client side. On the client side, we process it and store it on the client side. But of course, we also have this thing here, a lot of text here. We have the detect and send changes, and what we want to do is first of all have a variable that we store the old data, and remember that has to go in the container itself, otherwise it's not going to work. What we want to do is go through all the players of this container, so that's the for object player craft this, and then for each well, information we want to send, we go through and check if there's a difference there, as you can see on the left there. If the data has changed, we want to send the data to the client. And we're using the same thing as before. We use send progress bar update, so the same method on the client side will receive that information. And in the end, after we're going through all the players, what we want to do is save the data as the old data, which basically means that next time we check, we can compare it with what values we had last time we actually sent anything. So we only want to send the changes, otherwise we would have to send information all the time. So how this is set up is, when we open the interface, we send all the information. Well, all the time we check if something has been changed, and if something has been changed, then we send it to the client, and then the client can receive it and process it. This is very good because then we, first of all, we make sure that the client will receive the information when it needs to. We send all the information when it starts, and second of all, we only send information when it has been changed, and third of all, we're only doing this when the interface is open, so we don't have to synchronize data when it's not necessary for the client to know about it. We only need the information when the interface is open. And that's pretty much it for today. Remember the questions and exercises document. We have the questions to see what you've learned, exercises to practice a bit, and further explorations to go a bit further. Answers and possible solutions are supplied in the end of the document. But that's about it. This has been Climbing the Interface Ladder, lecture number 3, customized interfaces. I've been VSWE, and I hope you enjoyed it. Next time we will talk about advanced interfaces, so we'll take dig deeper into interfaces and see what we can do. We're going to talk about a few things there, but that's tomorrow, so I'll see you then. Goodbye.